We're going to start our unit on quadratic relations, or our first unit on quadratic relations, by doing some warm-up and reviewing the idea of simplifying like terms and so forth. So we're going to review how to simplify like terms, and then we're going to review how to simplify and plop like terms into expressions and so forth. And then we're going to take a look at some of the characteristics of a quadratic relationship. And that's something that we're going to be working with continuously over the next 2 units. So we'll begin by doing a quick warm-up and simplifying two polynomials. And again, a polynomial is an expression that has a whole bunch of different terms inside of it. Okay, and so in this particular instance, we've got 9x squared minus negative 10x plus 3x minus 2x squared. So again, the key thing about being able to simplify polynomials is, one, you want to get rid of the brackets first. Okay, and in this case there are some brackets and we can see them right here. We've got a negative 1 times negative 10 because in front of this bracket, since there's no number, it actually means that there's a negative 1. So it's actually negative 1 times negative 10. But when we're simplifying polynomials and trying to collect our like terms, remember, a term is like if the exponent and the variable are the same. Okay, and so we'll go through and we'll take a look at that as we go through. So what I'm going to do first is I'm going to expand out this bracket that I have here on the left-hand side. So that's going to leave me with 9x squared plus 10, because negative 1 times negative 10 is actually positive 10. So using the distributive property, I'm multiplying negative 1 times negative 10. So plus 3x minus 2x squared. So as I said before, in order for a like term to be in order for terms to be considered like, they must have both the same exponent and the same variable. Okay, and so let's take a look first and foremost at this 9x squared piece. So 9x squared, the variable is x and the exponent is 2. So we're looking for another term, and again, terms are always separated by either a plus or a minus sign. Okay, either an addition or a subtraction sign. So in this instance, we have 9x squared. The other terms here are 10, 3x, and negative 2x squared. Okay, and so in this instance, we see that negative 2x squared is actually a like term. Okay, so what we can do is we can rewrite that as 9x squared minus 2x squared. So I'm going to put that grouping of like terms together. I'm just going to quickly underline it so we can see what we've done. And then we're going to continue to look for other like terms. So other like terms, we've got a like term here that's positive 3x. Okay, and so I'm going to write in that positive 3x. So plus 3x. There's no other terms here that have x, and that's a second grouping of like terms. And there is a third group of like terms, and that's just positive 10x. Okay, and that positive 10x, because it does not have a variable, it is a like term unto its own. So when I go through and I collect my like terms, I can only ever add or subtract like terms. And so really there's only two like terms in this grouping. There's 9x squared and negative 2x squared. So the only simplification that I can do here is actually take 9x squared minus 2x squared. So I know that 9x squared minus 2x squared is going to be the same as 7x squared. Okay, so when you're subtracting or adding like terms with variables and exponents, the variable and exponent stay the same. It's just the coefficient, the number in front of the variable, that's going to change. So 9x squared minus 2x squared gives us 7x squared. The 3x remains the same. It's not being added or subtracted. We can't take 7x squared plus 3x to give us 10x squared because they're different terms. Okay, they're not like. So for example, even though 7x squared and 3x both have the variable x, they have different exponents. Okay, 7x squared has the exponent 2, 3x actually has the exponent 1. And so 2 and 1 are different numbers, and therefore they are different exponents. And then lastly, we've got the positive 10. And again, there are no other terms that are like positive 10, and so 10 remains the same. So our final answer there, in simplifying it, is 7x squared plus 3x plus 10. So now we'll take a look here at the second example on the right-hand side. And again, what we need to remember is if we have brackets, we need to expand. So in this instance, because there's no coefficient in front of the bracket, there's no number in front of the bracket, we know there that the actual number there is 1. Okay, so there's a negative 1 times everything in the bracket. So what I'm going to do is I'm going to take negative 1 times 3x squared and negative 1 times negative 2. Okay, so now I'm going to write this out in expanded form, and then I'm going to simplify it. So I've got negative 5x squared plus 2x. Okay, that hasn't changed. We've done no operations on that yet. Now I'm going to do negative 1 times 3x squared, and that gives me negative 3x squared. And negative 1 times negative 2 is actually going to give me positive 2. So now what I need to do is, again, collect my like terms. So quickly we want to identify, well, what terms are like? And again, like terms must have both the same variable and the same exponent. So negative 5x squared and negative 3x squared are like terms. Positive 2x, there are no other terms with just a single x variable. And finally, the positive 2 on the end is on its own. Okay, so there's no other term that is just a number, just a coefficient. So now I'm going to actually go through and simplify. So what I'm going to do is I can take negative 5x squared minus 3x squared. So negative 5x squared minus 3x squared. Again, plus 2x plus 2. So negative 5x squared minus 3x squared is actually equal to negative 8x squared. And I can only simplify like terms. There are only two like terms there to simplify, so therefore I've now simplified all of my like terms. And all of the other terms that are in the expression, I just write them out because I can't simplify them any further. So 2x plus 2. Okay? So again, when you're simplifying like terms, the critical piece here first is to expand out any brackets and then collect your like terms. And like terms have both the same variable and the same exponent.